Hey there, let's take a look at factoring. Factoring is kind of the reverse of multiplying or distributing. And so when you think of doing this in algebra and we're going to multiply 5x times this quantity, we would typically distribute that. Okay, so that's something we've done throughout this course. So we would end up with a 5. Now we haven't done a lot of this. X times x, that's x squared. And then a 5x times a 4 would get us a 20x. That's distributing. All right, what you're doing is you're multiplying. If you are factoring, you're trying to do that backwards. In other words, you're starting here and you're trying to get to there. So what you have to do is you have to look at what factor goes into 5x squared and into 20x. And ideally you recognize that 5 would go into both of those. But in addition to the 5, they each have at least one x. This one's squared, but this one has at least one. So the common factor would be 5x. And if I factor that 5x out, factoring is dividing. So ultimately what I'm doing is I'm taking this 5x squared and I'm going to divide it by this common factor. So 5x squared divided by 5x would just be x plus, and a 20x divided by a 5x is 4. So you can see that after you pull out the common factor, you're back to this. Okay, so that's our goal, is to work backwards. So let's try that. Looking at this is a trinomial. We have 3 terms. You have to think of, let's start with the number. What number goes into 4, 8, and into 20? All of them. 4. Okay, then you look at the variables and say, how many variables do they each have? At least how many would they each have? Well, this one has 3, but this one only has 2. This one doesn't have any. So there's not really an x that I could pull out because the 20 does not have an x as part of its factors. So all I can pull out is a 4. So when I pull out that GCF, then I'm dividing, because remember you're undoing the distributive property there, you're going to divide everything by 4. So 4x cubed divided by 4 would just be x cubed. 8 divided by 4 would be 2, and the x squared is still there. And 20 divided by 4 is 5. And then if you were curious, you could always redistribute that and see if you got the same answer. Because if you redistribute, you should be back where you started. Okay, we're factoring out a GCF. That's the greatest common factor. Let's look at this one. What is the greatest common factor? What is the biggest number that goes into 18 and into 3? Should be 3. Okay, and then let's look at the variables. This one has an a squared, so that's like having an a times an a. So there's a couple a's sitting there. This one just has one of the a's. All right, so you can only factor out what they both have, and they both have at least one a. So I'm going to factor out a 3 and an a. And then what I do is I divide each term by 3a. So 18 divided by 3 is 6. And if I had an a squared, that's like an a times an a. There's 2 a's sitting there, and I factored one of them out, then there's still 1 sitting there. Plus 3 divided by 3 is just a 1. And there was an a, but I factored an a out, so there's nothing left there. I have to put a 1 there. When you factor the entire term out, this whole term got factored out, then you have to leave a 1 in its place because you're dividing ultimately. But also think of it as you have to be able to redistribute, and you still have to have that term sitting there. So when I redistribute it, if I take it times 1, that 3a will be there. Okay, you try this last one. See if you can do that one. I'll wait a minute while you do that. Yeah, you thought I was kidding. I was going to wait for you. All right, I waited. All right, what's the GCF? What is the greatest common factor? So look at the numbers. You have a 10, a 30, and a 15. So the biggest number, the greatest factor of all of those would be a 5. Now you look at your A's. This one has 5, this one only has 2, and then the last one only has 1. So the most that you could pull out, oops, I got a little anxious there, is an A. So I'm going to factor out a 5, and I can factor out 1A. Now I'm going to come through and I'm going to divide everything by 5A. 10 divided by 5 is 2. It was an A to the 5th, but since I factored one of them out, I still have 4 sitting there. Plus 30 divided by 5 would be a 6. It was an A squared, but since I factored one of them out, I still have 1 sitting there. Minus 15 divided by 5 is 3. There was an A, but since I factored one A out, there's no A left with this term. I'm done. All right, hopefully that's what you got. Let's keep going. Okay, so let's look at this another way. Rather than looking at distributing, let's make it a little fancier. And instead of having just a monomial, a single term out in front, we're actually going to multiply 2 binomials together. All right, remember there's an acronym for that tells you that, oh, I'm going to multiply 2 binomials. That means I'm going to do FOIL on it. Okay, that's just an acronym to remind you that you're going to take the first terms and multiply them. That's the x and the x. First, and then you're going to do the outer terms, and you're going to multiply those. Then you're going to multiply the inner terms, and then the last terms. Just an acronym to help you remind everything that has to get multiplied. Now let's try it on this one. So the first is x times x. The outer is x times 4. The inner is 3 times x. Last is 3 times 4. And then what typically happens are these two terms are like terms that get to actually get added together. So now I'm at 7x plus 12. All right, so that's what you've done, and we've probably even done a little bit of that here in geometry, but our goal today is to factor. So instead of me multiplying, I'm going to factor, which means divide, which means go backwards. I'm going to give you this trinomial, and I want you to work your way back to these 2 binomials. Okay, so you have to pay attention to where everything's coming from. So if you look at this, the 12 that they gave me came from multiplying the lasts. So the last, which are your 2 numbers, are going to have to multiply to get you this number here. But that's great, but 3 and 4 are not the only things that multiply to 12. How did I know it was 3 and 4 instead of 6 and 2? Could have been 6 and 2. All right, that comes from the outer and the inner. The outer and the inner are going to add up right here. They're going to be those like terms in the middle that add up to get you this. So what you need to do is you need to find numbers that multiply to 16 or multiply to 12, but also will add up to 7. That's how we know it's 3 and 4 and not 6 and 2. Okay. All right, let's go on to the next page and we'll practice one. Okay, I guess we're trying more than one. All right, let's start here. Okay, x squared plus 2x minus 35. Here's what I'm going to do. I'm going to set up my parentheses first. Let's always do that first. Set up your parentheses sets. Okay. Now I know that the firsts are always going to get me this x squared. So that's just going to be x times x. So I'm going to put x and x. Now the last, I'm going to go here and here. Those are the last. And they're going to multiply to get me a negative 35. Okay, well there's kind of 2 main factors of 35, and that'd be 7 and 5. But in order for it to be a negative 35, I would have to have a 7 times a negative 5, or I could have a negative 7 times a positive 5. Those are the main factors. It could be 1 and 35, I suppose, right? But look at what I'm shooting for here. I'm shooting for this 2x. Remember, they multiply to negative 35, but they also have to add up to 2, a positive 2. So when I look at my 2 options here, which one adds up to a positive 2? Well, it should be these 2. A positive 7 with a negative 5. Those 2 numbers would multiply to this, add up to this. So what you do then is you just plug those two numbers into your binomials. So it's a positive 7 and it's a negative 5. And those are the factors of this trinomial. And so what we just did is factor the trinomial. You can see up here in the heading, we are factoring trinomials that are in this format. You're going to have an x squared, you're going to have some middle term here with an x, and then you're going to have some constant out at the end. All right, let's try again. Let's do this one. Set up your parentheses. First, get me that x squared. Got to be x and x. All right, now I want factors that are going to multiply to 16 and add up to 10. So if I think in my head, and I'm going to write them out, but you don't have to always write them. Maybe you can do it in your head. It all depends on your mental math skills. But I know 4 times 4 would get me a 16. I know that 2 times 8 would get me a 16. I know a 1 times 16. Oops, that's kind of messy. Sorry. Let me clean that up. And a 1 times a 16. All of those are fair game. Now, which one of those, though, also adds up to 10? All right, you should be looking at 2 and 8. Okay, now, one thing to think about on your signs is since this was a positive 16, then I know that both of my signs would have to be the same, because a positive 2 times a positive 8 would get me a positive 16. But wouldn't a negative 2 times a negative 8 also get positive 16? But the trick is that when I add them, I want to get this positive 10. And in this case, I'd get a negative 10. So I like the answers I had. They both need to be positive. So it's going to be a plus 2 and a plus 8. Now the order that you do, that does not matter. You might have instead written 8, x plus 8, and x plus 2. Same thing, doesn't matter. Either way is fine. All right, so I think what we're shooting for here is if this is negative, then I know my signs will have to be different. That's how I get a negative number. But if that sign is positive, then my signs will have to be the same. And to decide are they both pluses or both minuses will depend on this sign right here. Since I wanted it to be a positive 10, my signs were both going to be pluses. But I could have a plus sign here, and if this were a negative sign, then I would have opted for this. And this would have been a minus 8 and a minus 2. All right, keep practicing. And this next one, x squared plus 9x minus 36. Okay, minus 36, that's tricky. 36 has a lot of factors. So I'm going to put in my x and my x, and I'm going to start listing them out. You tell me when to stop. Tell me when you found some. Now, since it's a negative 36, I know that I want one of them to be positive and one of them to be negative. So I could go like with a positive 1 and a negative 36. I could go 2 and negative 18. That multiplies to negative 36. I could do 3 and negative 12. That multiplies to negative 36. 4 and negative 9. 6 and negative 6. Oh my gosh, I forewarned you. There's a lot of options here. Okay. The trick, though, is that I want to end up with a sum of 9 when I add them. Oops. When I add them, I want this sum of 9. So which one of these would add up to a positive 9? And ultimately, when you look at it, none of them do. But this one right here to a negative 9. So I could fix that. I'm just going to make the 3 negative and the 12 positive. Now they still multiply to negative 36, but they add up to a positive 9. So I'm going to do x minus 3 and x plus 12. And again, the order that you do that doesn't matter. If you had opted for plus 12 and then an x minus 3, that would be acceptable as well. Doesn't matter at all. You just got to make sure you get your signs correct, though. The 12 needs to be positive and the 3 needs to be negative. Okay, let's try one more together here. So you've got x and x gets you your x squared. factors that multiply to 9 and add up to a negative 10. First thing that jumps out in my mind is a 3 and a 3, but that does not add up to 10, so I'm going to go with 9 and 1. The positive means my signs have to be the same, but the problem is 9 and 1 add up to a positive 10, and I want it to be a negative 10. So I'm going to make both of my signs negative. Now I have a negative 1 and a negative 9. That would get me my negative 10x. All right, if you can figure out the factors without drawing them all out like I did right here, that's great. You don't need to list all the options. That's just in case you need that help. Okay, so what I'd like you to do now is practice on your worksheet for a little bit with just some problems like that. See if you can get comfortable with that, finding what factors would fit. All right, so I want you to pause the video right now. Go do your homework. Once you've done, I don't know, half of the front page, come back to me. All right, I'm going to assume you've done a practice with some of those trinomials. I wanted to throw a couple other types of problems at you. These are super common, so I wanted to be sure we went through this. These are not trinomials. These are binomials. There's only 2 terms instead of 3 terms, but it will still factor. It's called a difference of squares. Difference meaning they're always going to be subtraction. You can see, yes, always subtraction. And difference of squares means both the first term and the second term are going to be perfect squares. So remember from yesterday, our perfect squares, square root nicely, these are perfect squares. These should look familiar. Okay, even this is a perfect square. And here you got a 16 and a 1, that's a perfect square. Here's how you're going to factor this. Ultimately, here's what's happening. You have an x squared. There is no middle term, so we think of it as a plus 0x minus 64. So you're looking for 2 factors that multiply to negative 64 but add up to 0. And here's what's going to happen every single time. Well, it'd have to be 8 times 8. But since it's negative 64, one's a plus and one's a minus. And that's where this 0 comes into play. Okay, your first term is an x squared, so you're going to break that up x and x. All right, this little pattern right here is how always to factor a difference of squares. They're almost identical, except one's a plus and one's a minus. And that's because these are perfect squares, so you're going to use the same number twice on them. But again, it's a difference, so you'll have to have one of them positive and one of them negative. Let's do the next one. Okay. First is x and x. Last is a negative 100, so it has to multiply to a negative 100. I'm going to do positive 10, and I'm going to do negative 10. And here's what happens. You don't need to write this, but that's going to get you, when you're doing your FOIL, you're going to get first, there's your x squared, and the last is going to get you that negative 100. But what you don't notice happening is the outer is a 10x and the inner is a negative 10x. And what happens is the outer and the inner end up canceling out every time. That's why it's only a binomial after you FOIL it back. Okay, next problem. I threw a coefficient on the first term, so it's not x and x, it's going to be 2x and 2x. Because you're just doing the square root of 4. That's 2 and 2. And the square root of 25 is 5 and 5. One of them's a plus, one of them's a minus. That's all there is to it. Last one. Square root of 16x squared. That'd be a 4x and a 4x. The square root of 1 is a 1 and a 1, but one's a plus and one's a minus. So they really, once you get the hang of them, factor very quickly. I think there's a few problems on your homework that are a difference of squares. So you might want to pause the video for a minute, go practice a few difference of squares, then come back to me. You're going to know it's a difference of squares because there's only 2 terms instead of 3 terms. All right, the reason we're doing this today is because it's going to pop up in the next chapter when we have to solve quadratic equations. The term quadratic is a mathematical term that means that you have an x squared in your equation. A quadratic will always have an x squared. So everything we do has this x squared in it. I'm trying to get an x squared there. Can't make it, won't write. Okay, sorry, I don't know. There we go, x squared. That's what quadratic means. Now, to solve them, though, that's what's new. So now it's going to equal 0. And if it equals anything other than 0, your first step is to get everything on one side. You might have to subtract some stuff over, but it needs to equal 0. All right, so we're going to solve these now. So it's going to look the same, except now it has an equal 0 on it. So on this one, I'm going to factor it. So it's going to be x and x, multiplies to 21, adds up to 10. Should be 7 and 3. All right, this is a plus sign. That means my signs would have to both be the same to get a positive 21, and they're both going to be that. So they're both pluses. Okay, now here's what's new. It equals 0. So I'm trying to solve. So think about this for a minute. You don't need to write this, but think about it. I'm going to take some number. I'm just going to make it up, a. And I'm going to multiply it by some other thing, b. And I'm going to tell you that it equals 0. Now think about what must happen for a times b to equal 0. When you multiply two numbers together, how do you end up with a 0? Okay, one of these is going to have to equal 0. That's the only way that works out. So that's what I have going up here. I'm taking this quantity times this quantity, and I'm telling you it's going to equal 0. These are being multiplied in between here. So what that means is that the x plus 3 has to be 0, or possibly the x plus 7 has to be 0. That's the only way that would play out right. And then you solve. Minus 3 on both sides. So x would be a negative 3. Or possibly over here, x could be negative 7. And I have two because it equals 0, I have two different options on making that equal 0. Either x is negative 3 or x is negative 7. All right, let's practice again. X and x multiplies to 10, adds up to a negative 11. Think about that. Multiplies to a positive 10, adds up to a negative 11. It's not 2 and 5, it's going to have to be 10 and 1. A positive 10 means my signs are the same, but because it's a negative, I want them to both be negatives. So you can see the last would end up giving me, when I multiply last, I'd get a positive 10. But outer is negative 10x, inner is negative 1x. There's your negative 11x. All right, keep going though, because you've practiced that enough. Now let's do the solving piece, which means you set each of those equal to 0. So x is going to be 1, or possibly x is going to be 10. I'm just adding the 1 to the other side, adding the 10 to the other side. I have two possible solutions. All right, let's try again. Getting faster now. X and x multiplies to negative 30 and gets me a, oh, my screen is hiding that. I can't tell. Is that a negative 7 or a positive 7? I can't tell. There it is, plus 7. Okay. All right, so, gosh, this is the trickiest one we've come across really in a while. So let's see. 30 multiplies to 30 could be 5 and 6. But it's a negative 30, so one of them is going to have to be negative. That's not going to add up to a 7, though. How about 3 and 10? But one of them has to be negative. Okay, I think I have it right there. Negative 3 and a positive 10. That's going to get me my positive 7. So I put in negative 3 and positive 10. Now I'm going to set them each equal to 0. And so I have x equals, on the left side here, I'm just going to add 3, But on the right problem, I'm going to have to subtract the 10. So my solution, x would be 3 or negative 10. See if you can do this last one. All right, I ended up with a negative 2 or a positive 12. Okay, so if you agree with that, that's great. If not, look that over and see what I did and see how we differ. Now at this point, what I'd like you to do is just finish up your homework, all right? So you have a worksheet, there's front and back. The front page you're just kind of factoring, and then on the back page I start throwing in the equals 0. That's how you know that you're doing it the next level, where you're actually solving, is if it equals something. And that's where we actually start applying this in our geometry, is when it equals something. Practice that. Okay, so then let's go back to those other types of equations, and we'll do that solving that we just got done practicing. Notice all of these equal 0. So same thing that we were just doing, only notice these are not the trinomials. We're doing the other kind of factoring. So when you look at this, see how this is a difference of two perfect squares? Remember how the difference of squares works? You're going to have an x plus 5 and an x minus 5. But now it equals 0. So you'll set each of those equal to 0. On this first one, you're going to subtract the 5, so x will equal negative 5. On the second one, you're going to add the 5, so x will be positive 5. So these are your two options to make that equation true. All right. The second one over here to the right, it's similar. It's also a difference. Notice the subtraction. Difference. These are both perfect squares. But it's a little bit fancier. Instead of it just being an x squared, it's a 4x squared. So instead of x and x, I'm going to put 2x and 2x. And then factors of 81, just square rooting it, 9 and 9. And then one has to be a plus and one has to be a minus. All right, so now let's set those each equal to 0. Okay, subtract the 9 on both sides and then divide by the 2. So x would be a negative 9 halves. Over here, I'm going to add the 9 to the other side and divide by 2. So it could be a positive 9 halves. So those are your two solutions. That's how it works if you're doing a difference of squares. Okay, on this next one, we are doing, this is not a difference of two squares because 7 is not a perfect square. So this is more the type that's a GCF. Like what could you factor out in front? So in this one, I could factor out an x. They both have an x. Okay, so then I have an x left in that first term minus, when I factor the x out of the second term, I just have a 7 left. Now this looks a little bit different, but you're still just multiplying right here. And if I'm going to multiply these two things together and say it equals 0, then either this is 0 or this quantity is 0. So I would set it up x equals 0 or x minus 7 equals 0. So nothing happens with the x is either 0 or x is add the 7 to the other side. So you have those options. Okay, last one. Why don't you try this one on your own? Looks again, it's not a difference of squares, it's a GCF problem. See if you can factor out the GCF, then set them each equal to 0. I'll wait for you. Give it a shot. All right, see if you agree with me there. I ended up with a 0 and a -8 for my solutions. All right, so that's what we got. That's kind of your review of factoring from Algebra 1. Now, at this point, I want you to go finish your worksheet. Hopefully you've already worked on the front side, so it's just the back side now that you start setting things equal to 0. So then you go to that next level of finding actual solutions. If it doesn't equal 0, then you stop back here at the factors. It's not until it equals 0 that then you would have this kind of an answer. Okay, I'm going to throw one more thing at you here. I still want you to go finish your worksheet. I just want you to go do that right now. Now let's say that this is pretty easy for you. Like you have some good mental math skills and this is pretty good. When you finish this, I'm going to keep going on this video, but it's an optional thing, and it's for those of you that are moving on to Algebra 2. I'm going to add one more special thing in there that makes it a little bit trickier. Again, it's optional, but you know, it's kind of fun. So especially if you're good with your mental math, come join me, all right? And I'll show you the extra that we've got. But first, go get good at this stuff. Go practice, go do your worksheet. Come back over the weekend if you want. All right, ready, go. All right, so here's the bonus material. Here's what's new. What's going to be new is there's going to be a coefficient on your x squared term. And that throws a whole kink in the mess. Let me show you. All right, so again, we're going to start off and think of this backwards. So I'm going to do first, I'm multiplying the two binomials. 2x squared. Outer plus 8x. Inner plus 3x. Last plus 12. Combine the like terms there. So now, here's my goal. I'm going to give you this, and I want you to get me back to that. Now, here's what the problem with this is, though, is that when you got your, okay, so yes, factors of 12 would get me my 3 and my 4. I get that, right? But all of a sudden, it's not going to just be an x and an x, because I have a 2x squared. So it's going to have to be a 2x and an x. But here's my question for you is, yeah, I can see that it's 3 and 4 because I started with 3 and 4. That makes sense. But 3 and 4 does not get me this 11. Remember, we would add those up and get an 11? Get 7, not an 11. So where is the 11 coming from? Well, it has to do with the fact that the 4 got multiplied by that 2 that was out in front. So that's going to change the 4 into an 8x. So how do we anticipate that happening? How do we work through that? Let's look. 2. what just happened? All right, so 2x squared now this really becomes a little bit, don't be afraid to do some erasing. You're going to do some guessing and checking. That's what we're going to do. We're going to try some stuff. If you're still with me, if you're doing this with me, then I'm going to say that you are probably pretty good with your mental math. And this is maybe a little bit fun. It's okay. You can say it. I say it. It's kind of fun. So I'm looking for factors of negative 10. So I'm going to come over here and I'm going to think, all right, I've got, it could be negative 10 and 1, I suppose. Could be negative 5 and 2. That would work. It might be the other number that's negative, though. I don't know. But I'm going to leave it for those two options for right now. But I know that when I plug these numbers in, one of them is going to get multiplied by this 2 that's right here. So it's not as simple as they multiply to negative 10 and add up to 19. You can see none of mine add up to 19. So I have to choose one of these options. I'm going to plug them in. But I know that when I do the outer, it's going to get multiplied by 2. All right. I guess I'm going to start with my first one. I'm going to put in negative 10 and a positive 1. And then I'm going to check. And remember, guess and check. So that's a positive 2 for outer and a negative 10. I guess I'm going to go ahead and write this. For right now, I'm going to write, like I said, we're going to write, erase. But ultimately, you'll eventually do this in your head. That works great for getting my negative 10, but those outer and inner are going to add up to a negative 8. I want this. So what I'm going to do then is I'm going to erase. Maybe I'm going to erase. Is it going to let me erase? Come on. It's not going to let me erase. That's going to be bad news if I can't erase. Pause. Hang on. Well, that stinks. I had to undo. But whatever. Okay. So what I'm going to do, I'm going to keep undoing, because what I'm going to do is I'm going to trade. Here's what the deal is. Maybe I just need to swap my 10 and 1. And so I'm going to keep undoing. And I'm going to change it to putting my 1 here and my 10 here. One of those is negative. Could you think about which one you want to make negative? All right, hopefully you're saying that one. You start to think ahead a little bit, and you say your outer would be a negative 20, and your inner is a positive 1, or a 20x and a 1x. Right there's your negative 19x. We've got it. We figured it out. All right, now if that didn't work to swap the 1 and 10, then I would bail on the 1 and 10, and I would go with the 5 and the 2. But that's not the case. I found it to work. So there's my answer. All right, let's try again. Here we go. Factors of 3 are going to have to be a 3 and a 1, and then an x and an x. So I'm not even going to bother to write the 1x. I'm just going to write x. Now, factors of 7, I'm in luck here. There's only 2. I mean, it's got to be 1 and 7, but it's all about where do you want to put it so that your outer and your inner end up giving you this negative 20 that you want. Now, your outer, or I'm sorry, your 7 is negative. So you know you're going to have one of them positive and one of them negative. Okay. What do you, they're going to be different signs. So ultimately, your outer and your inner are going to end up subtracting to get you this 20. If you think about it, I think I want that 7 to go there, because that's going to get me a 21x. And so 7 and 1 are my two factors. So that would work, right? A 21x and a 1x, because I know my signs have to be different. So one of them's a plus, one of them's a minus. But I want it to be a negative 20, so I'd want my 21 to be negative and my 1 to be positive. So for my 21 to be negative, I'd have to have a negative on that 7 and a positive on the 1. And then you have your factors right there. I didn't even have to erase on that one. Let's try again. Now notice I'm not solving here, we're just factoring, and these don't equal anything. So once I have the two binomials set, that's all I want. And I notice I'm boxing that in because all this extra stuff is just clutter after a while. Okay, 3x squared, gonna have to be up 3 times a 1. Factors of 20, somehow they have to multiply to 20. That could be a 4 and a 5. That could be a 2 and a 10. Could be a 1 and a 20 if I wanted it to. But one of them is going to get multiplied by this 3. And one of them is not. And somehow those have to add up to this negative 17. Now what's different on this one is it's a positive 20. So that means my signs would be the same. But they're both going to have to be that negative. For them to add up to be a negative, I'd want them to both be negative. Both be negative. Both be negative. Something there. Okay. But again, one of those is going to get multiplied by this 3 over here. And then one of them is not. Can you figure out a way? So this time, since these are both going to be minuses, you want these two numbers to kind of add up to be that negative 17. I'm going to give you a minute to look at it. What do you think? All right, so I gave you a minute to think because I want you to eventually get to the point where you can just do that in your head, but we maybe aren't there yet. That's okay. I'm just going to put in my 4 and my 5, and let's just try. All right, that's a negative 15, and then the inner is a negative 4. And that does not add up to 17, so that's not correct. I know that that's not what I want. Oh, there my eraser worked. I don't know what was happening last time. Okay, so I don't like the negative 4 and 5, so typically the strategy that we go with is stick with the 4 and 5, but trade them. Because maybe the other number needs to be multiplied by 3. So I'm going to trade the 4 and 5. Now let's see what we got. That's a negative 12x, and this is a negative 5x. Hey, there's negative 17x. Did you have it already? Good for you. Now, if that did not work and I had tried it both ways, then I forget the 4 and the 5 and I jump to 2 and 10 and see if those work. Okay, we got one more here. Factors of 2. 2x and x. Factors of 6. I could go with a 2 and a 3, or I could go with a 1 and a 6. Looks like the signs are going to have to be the same, and I'm going to want them both to be minuses. Okay, so it's going to look like that and that. And down here, that means they're both minuses. Okay, somehow or the other, I need the outer and the inner to add up to a negative 7. See, I'm going to give you a minute to think about it before I put in some numbers. All right, I'm going to try 2 and 3. The outer would be a negative 6. Sorry. Okay, so negative 2x. All right, that does not get me what I want. I want a negative 7. That's going to add up to negative 8. So I'm going to erase. Or not. It's not. Oh, there we go. There we go. Sort of. I only get to erase some things, apparently. My bad. All right. So what I'm going to do is I'm going to trade this. I'm going to make this be the 3 and this be the 2. Don't do what I'm doing. Don't scribble over the top of stuff. I can't read that. Okay, so it's a negative 4x and a negative 3x, and lo and behold, that adds up to negative 7x. So I've got it 2x minus 3 and an x minus 2. Those are the factors of that trinomial. All right, so let's now change it up. Now we're going to add in the equals 0 to it. So we're going to factor it and set it equal to 0. I'm going to shift this up so I have a little bit more room. Okay. All right, so we're going to start off and we're going to factor. So let's do that. Set up your two factors. All right, I've got a 3x squared. So instead of x and x, it's going to have a 3x and a 1x, or just x. Now, I'm trying to find factors of 15. So they got to multiply to 15, but they got to add up to 4. But remember, one of them's going to get multiplied by that 3. So it's not just that. So here are my options. I guess I've got 1 and 15, and I've got 3 and 5. Those are my factors of 15. Now, because it's negative, one of those would have to be negative. All right, so now picking those, I typically go for kind of the middle of the road ones, the 3 and 5, versus those extremes, the 1 and 15 are so far apart. So I'm going to go with the 3 and the 5. Now the trick is though, which one needs to get multiplied by that 3? And I'll give you a minute, you've done a couple of these now. See if you can think through the 3 and the 5, which one do you want to get multiplied by the 3? Notice that your signs are different, so your outer and your inner will need to subtract to get to this 4 right here. All right, I'm going to try it. Let's throw in a 5 here and a negative 3 there. That's what I had. Okay, there I have an outer of 15x, inner is negative 3x. And that does not get me a 4. So that makes me think I'm wrong, and so I'm going to trade the 3 and the 5 and see if I can get that to work. So I'm going to put my 5 here and my 3 here. So that's going to get me a positive 9x and a negative 5x. Now when I add those up, I do get that positive 4 that I want to have. So I think I found it. Now just a thought here, I don't think this has happened to me yet, but if I had ended up with a negative 4 out of that, that just means my signs were wrong, and I would just swap where the signs are. All right, let's try one more. Oh, wait, I'm not done. This is an equal 0. So after I found my factors, I grab each one of those factors and I set it equal to 0. Now because you have a little fancier binomial, the solving of it, you get a little weirder answer. So you're going to have a 3x equals 5, and then when you divide by 3, you'll have 5/3. So you're going to end up with some fraction answers. The second one, I just have to subtract the 3, and I've got it. Okay, let's try one more. This one here, I'm going to set up my binomials. It's a 2x squared, so that's a 2x and a 1x. Now I'm actually in luck here because this is a 7. 7 only has 7 and 1 for factors. So you want your outer and you want your inner to add up to a 9. It's a positive 7, so your signs are going to have to be the same. They're both going to be whatever that is, so they're both pluses. I bet you can do this. It's 1 and 7. Where are they going? Okay, hopefully you said there, because that's going to get me a 2x for outer and a 7x for inner, and there's my 9x. Now, because it equals 0, I'm going to keep going, and I'm going to set each one of those equal to 0. Okay, on this first one, I'm going to subtract the 7, and then I'm going to divide by the 2. On the second one, I just have to subtract the 1, and I've got it. All right, so I don't really have any part of your worksheet doesn't have this coefficient of having some number in front of it. Now I don't have that. Maybe I'll make up a Math Excel, and if you get some time and you want to play around and see how you can do on it, give it a shot. It'll be optional, but you know, it's kind of fun. You can say it. All right, thanks for joining me. Bye.